Hello, everyone. Welcome. We will be starting very shortly. So could everyone find their spots soon?
Welcome, everyone. Thank you for joining us today. We've been counting down the moments till we could gather with you all today, our supporters, our family, and our friends for this momentous unveiling of the UT25 car. What we're about to share today is our passion project, our midnight obsession, and finally, our pride and joy. Before we begin, we wish to acknowledge this land on which the University of Toronto operates. For thousands of years, it has been the
problem. Dean Yip, can you help us solve this problem? We've got that. I'm like, I am all in to solve your guys' problems. So I want to congratulate you again. This is an amazing achievement. I'm so looking forward to what you will unveil. I'm looking forward to seeing how it runs. And I'm looking forward to trying to get over to Europe, actually, and follow the competition this summer. So congratulations. Looking forward to this unveiling. And thanks, everyone, for being here tonight.
Thank you, Dean Yip, for your thoughtful words and your ongoing support. Your guidance have made a meaningful difference in our team. Now, I'd like to introduce you our team principal, Ayrton Antonucci.
Thank you. Yeah, thanks. It's hard to follow up with from the dean, but I'll do my best. Thank you, everyone, again, for being here. I do speak on behalf of the whole team in saying it's a pretty awesome privilege to be able to, showcase our work here today in front of all of you. So this is UT25. It's our 4th ever electric vehicle and our 26th as a team. So everyone on the team is now younger than the team itself. So we've got a lot of foundation to build from, which is awesome. And as the dean alluded to, the last couple of years have been tremendously successful. We've had back-to-back wins in New Hampshire, top 10 place finishes in Michigan, which is the biggest competition in North America, and had gotten to go to Europe in 2023 and got top 10 there at FS Czech as well. So it's been fantastic so far, and we've had a good going of it. And in doing that, that means that for the last 5 competitions we've attended, every endurance event, which is the main kind of event at the end of the competition, we have finished. And for those familiar with the series, that's actually kind of a miracle. And that doesn't happen often. So we're obviously very proud of that, but it also gave us an opportunity to build from. And it gave us an opportunity to say, look, how can we take a big leap from that? We have a reliable foundation now. How can we make a drastic change and cement ourselves as one of the teams in North America that's setting the standard, setting the bar? So that's a difficult thing to do. So it all kind of began with, how do we take, we have to become, we're a good student design team, and we want to become like a great, ambitious, student racing team. Like, what's the difference? So that's all, that whole process, it began with, we took a look back and we said, okay, we need to add some skill sets to the team that we don't have right now. So what we did is we introduced 2 new sections. We've got vehicle dynamics and race engineering now as part of the team. And what those have been able to do is now we have a foundation upon which all of our design can build from, this vehicle design philosophy that's rooted in performance. And that's been really great because it's allowed each one of our design sections to collaborate and integrate with each other and ensure that they're actually fulfilling that vision cohesively. So that has been a great success so far. The race engineering side of things is focusing on how we actually perform, so our execution, how we prepare and how we organize ourselves when we're there on the day at competition. So that's obviously going to be a tremendous part of the next month or 2 before our competitions. And race engineering itself is also about training our drivers because we don't want to show up with a beautiful car and then ruin the competition because our drivers don't know what they're doing, which, again, student teams, that happens pretty often. So yeah, so that's how we wanted to restructure the team. And in terms of how we wanted to approach everything, a lot of effort has gone this year into the car this year in doing things differently. So we really made a strong push to challenge everything that we had been doing in terms of the design previously. And if there was an opportunity to be creative and try something new, then we took it. And if anything didn't work out, then it's always easy to kind of pull back from that, and you can readjust. But then you know where your bounds are, and that's really important, because if you're trying to push to be the best, then you need to know where that limit is. So that's where we've been really pushing, and a ton of effort has gone into that. And I think you're going to see that when we pull the tarps off, especially for those of you who have been following the team for a little bit. There's quite a lot of drastic change here. The final element of that, and perhaps the other side of the coin of it, is attention to detail. And it was is very nice to hear that the dean doesn't care about our grades. That's I suppose we need to graduate, but attention to detail is always difficult. That I think every engineer in the room would probably agree. The last 10% of a project is just as difficult as the first 90%, and that's because you really got to push it over the finish line often, and you have to maintain that quality of work. But that last 10% is the most important. And when you're students and you're paying a lot of money to not fail, that it sometimes becomes difficult. So that was a really big push for us this year, and it goes into really how that resolves itself is you have to take pride in your work, and we have to do that across the board, from our design to the way that we manufacture things, and ultimately how we prepare and organize ourselves, both at testing, at competition, and otherwise. So it's been a remarkable year, and I personally could not be more proud of every single member of this team, because they've put absolutely everything into fulfilling those principles, and I believe that you are going to see that when the tarps come off of the car this year. So thank you once again for being here. And now I'd like to introduce 4 people that have been absolutely essential in making that possible. And that is our mechanical technical director, Winston Young, our electrical technical director, Nicholas Burley, our driverless technical director, Yusuf Eltadad, and finally, but not least, our business director, Evan Tao. So these guys have, they've burned the midnight oil, like the rest of the team, but they've got to bear the responsibility of it. So, I'd invite you guys up to kind of one by one introduce us to your sections.
Hi, I'm Winston, and I've had the privilege of being the mechanical technical director for UT25 after taking over mid-season. The mechanical department is responsible for the design, test, manufacture of pretty much all the main physical components that you could reach out and touch on the car. So that's things like the aerodynamics, suspension, chassis, drivetrain, driver controls. And we're putting all that together. So behind me, you can see these are the faces of our fantastic mechanical leads. This group has been a privilege to lead. They've been incredible to work with, and they've really come together to overcome a lot of really unique and diverse challenges this year in a really, really impressive way. And without their unique expertise and their wide range of experiences, what we do simply wouldn't be possible. This year, we've completely overhauled several main aspects of our package. We have completely new aerodynamics, completely new battery, completely new suspension, and this has thrown a lot of really new and complicated challenges at the group. And easily the best part of my job has been seeing this group all the way from first years to section leads to 4th years or even master's students who are helping us out come together and overcome each of these new challenges one by one. This has truly been really impressive watching everyone just come together and tackle whatever this car could throw at us. A special group I really want to thank out of that is our senior members. These are the 2nd, 3rd, and 4th years who might not have a job title or a lead position on the team, but are still in the shop nearly every day doing things that just absolutely need to be done right. And without this immensely critical work, we just don't run. And that's a really important group that I want to acknowledge. This car has been our most ambitious yet, and we're really looking forward to seeing what it can do on track. With all those overhauls and also a really ambitious testing schedule, including visits to Multimatic's 4-post suspension setup and Ford's wind tunnel, we're going to have a ton of data and a ton of great opportunities to tune in our mechanical and aerodynamics package together so that we're sure we're going to deliver our best on-track performance. With all that under our belt, I cannot wait to see how we do at comp, and I can't wait to shatter the records this team has set before. Thank you.
Hi, my name's Nicholas Burley, and I'm the team's electrical technical director. What that means is I manage the 20-odd people who have spent the better part of their waking lives this year building our battery pack, making wiring harnesses, writing firmware, and soldering circuit boards. The electrical team does everything from building our 600-volt battery pack and powertrain that spins our motor to the low-voltage data acquisition systems that are constantly running on the car as it drives, all the way to the button on the dash that the driver pushes to turn the car on. What I really want to highlight this year is it's been a year of firsts for the electrical team. This is our first accumulator using pouch cells, which is a new type of cell that is much more energetic, but way more difficult to work with. It's thrown a lot of challenges at us, and we have risen to the challenge admirably. It's our first year with a custom battery management system, so replacing an off-the-shelf solution with something that we've built ourselves gives us a lot more control over our battery. It's our first year running a real-time operating system on our microcontrollers, which enhances our computational efficiency, improves our data acquisition. I want to say a huge thank you to all the leads and senior members and recruits on the team who have dedicated themselves day and night to making this work. Without you guys, this would not have happened, and it really is thanks to you guys. So I really hope that every single one of you is proud of what you've built. I know I am. And I have to say, I am really, really excited to take this car to competition. Thank you.
Hello, everybody. My name is Yusuf Haddad, and I'm the driverless technical director for UT25. So this year, our team is planning to compete in driverless events. And while these events have existed in some of the competitions we go to in Europe, this is the first year we're really going to be able to see them integrated into our North American competitions. These events are essentially the same as what we're used to with our regular dynamic events with a driver, except now this car has to do it completely on its own. And so the main goal of our sub-team is to enable exactly that. So the problem we're trying to solve is how do we get this car to move through the track without hitting anything and without running anybody over as fast as possible. And so to do that, I'm going to walk us through a bit of sort of the high-level architecture of how we make this happen. Essentially, we apply a fundamental robotics principle called see, think, and then act. So first, the car must be able to perceive its surrounding environment, plan out the path to take, and then execute that path. And so to start, we have our perception system, which gives us LiDAR and camera data. So the LiDAR gives us three-dimensional point clouds that we can then reference exact distances of nearby objects, and the camera gives us an image of what is directly in front of the screen. We then run an AI detection model called YOLO on our images to then classify the cones, as you guys see here in this picture. And at the same time, we run processing on our LiDAR data and begin clustering the relevant objects in the frame. We then remove the ground completely so that we're left with just these cones. And then panning the two together, this is where we run our Hungarian algorithm to then map these two and identify which one's which. So now we have precise coordinates for these cones as well as their color, which then allows us to come up with our cone detections. So these detections sort of define the bounds of the track. So this is exactly what the car's computer really is effectively seeing as we're driving. So once we have these detections, we're then able to map out the track, and using our other sensors like GPS, IMU, we're then able to localize ourselves within this track. And we're then able to also plan out the perfect path to follow. So for those of you who follow Formula, you're probably familiar with like the racing line. So that's exactly what you see there in green. And our control algorithms allow us to track this path directly and then controlling mechanical components on the car, like the steering motor and the inverter, to then physically get the car to move where we need it to go until we complete the track. There's obviously also a lot of electrical and firmware integration that comes into play here to make sure that not only our system works, but also other safety checks and procedures can run accordingly on the car to make it, obviously still work. But yeah, essentially in a nutshell, that is how our driverless system operates. And behind me here, these are the leads of this year that have made this possible, along obviously with other very dedicated members of this team. So yeah, thank you.
Good evening, my name is Evan Tal, and I'm the UT25 Business Director. Our focus on the team is to ensure that we have the right tools to be successful both on the track and off. There are many things that need to go well so that our hard work translates into on-track performance. The business department is comprised of 4 sections: external relations, marketing, graphic design, and events. It's been great to see over the past year everybody working so hard to not only refine but expand the scope of our department. One of our major goals this year was to improve collaboration both internally between sections and externally with the Greater Toronto community. One of the events that we put on this year, Women in Motorsport, was a great example of this. In January, we invited women in the motorsport field to come talk to the wider U of T community about their experiences. And the events team led this project, working with external relations and graphic design to put together a sponsorship package and reach out to the community for support. And the marketing team worked to promote and share the content of this event. It was great to see everybody come together and work collaboratively, both internally and with the community, to make this a success. I'm really excited to see the team continue pushing as we move on to case competitions at FSG and Michigan, and as we continue to finalize our final logistical plans of the season. Thank you.
So now to further walk through how the car came about, I would like to introduce to you guys our newsletter author, Aranya, to lead a discussion with our directors about the journey behind the achievement.
Round of applause for this car. She is something, huh? Well, all of you guys know that this was a long journey, a lot of sleepless nights, a lot of hard work, a lot of bad tests But what we're going to do right now is just going to walk you through each of the sections, ask a few questions, really get to know the journey behind this. So I'm just going to pass this mic down, and we're going to kick things off with mechanical. Winston, the car looks fast. It looks really speedy. I like the white especially. But can you walk me through some of the biggest physical changes we've seen this year?
Yeah, for sure, and it definitely does look great, if I do say so. So there's, some definitely really major architecture changes that you could see just from the outside. So to walk you through the three biggest ones, first of all, as I mentioned earlier, complete overhaul of our aerodynamics system. So we have a brand new front wing, which is more complicated in pretty much any way than anything we've ever built before for aero. And as part of packaging that, we've added these winglets onto the side of the chassis. We've reprofiled the nose cone. We've added brand new side pods, expanding the scope of our bodywork and design further than we've ever taken it before, as well as a pretty significant overhaul of our rear wing system. Sticking out of that nose cone that we had to redesign, you'll see our brand new Multimatic DSSV suspension system, which is contributing to more than doubling the tunability of our system and vastly increasing the parameters we can work with and helping us get that aero package in the optimum window, and also really contributing to our ability to set up the car for different competitions, different events, different circumstances. Finally, one more nice obvious change to point out is, thanks to centering tech, we have brand new carbon rims on this car, which are really helping to cut down our unsprung mass and overall hopefully making this the most competitive car we've ever put forward.
Wow. Yeah, I do like the suspension specifically. Thank you, Multimatic, once again. The blue looks nice. And, well, Ayrton earlier spoke about being ambitious, thinking outside of the box. And can you talk us through what is it like starting with that ambition, but 9 months later ending with something like this?
Definitely. So our design process starts, we started for this car way back in like May, June of 2024. And where we start is with a really high level, we call it our lap sim. So this is a simulation of how does the car go around a single lap and also stitching that together into a full endurance, which is 22. So how fast is it going around the lap? How is the car behaving at each corner, each phase? And what we're really looking for here is where are we leaving performance on the table? So what parts of the lap are we performing like suboptimally, and where do we think there's performance to be gained? So last year we were doing that, and the information we were getting out of that is we really needed an upgrade for our suspension system. And luckily that was able to work out. So we're very thankful for Multimatic for setting us up with that. So that moves us into the second stage of this process, which is the more detailed design. So we've identified the suspension and the damping specifically as an area where we can improve our performance. But then we need to think about, well, how are we going to do that? So which actual dampers are we going to select? Which springs are we going to use? How should we set up the 3D points of the suspension so we can obtain the kinematics we're looking for? All this sort of detailed stuff that leads to okay, well, this is the system we want to implement, and this is the parameters we want it to have. And then sort of around the time school's picking up, that's wrapping up at the end of the summer, so let's say September, we're moving into the mechanical design of that. So we know that we can have a suspension that has these parameters, but what is the lightest, stiffest way we can implement that on the car? So that's using tools like finite element analysis, optimizing the mounts, the geometry, thinking about how it's going to interact with the rest of the car so that it all works out. And last but not least is the design for manufacturing stage. This is finally, we've identified what we want, how we want to do it, how we want to obtain it, and then it's, well, can you actually build that? I'm sure almost every engineer in the room has designed something at some point that was actually physically impossible to manufacture. And you really don't want to do that, because then you'll sunk so much time into something that you just can't have. Or even worse, you end up messing it up in the process of manufacturing it because it was just too on the edge. So really what we're looking at there is we don't want to lose a 1/10 of a second of lap time by chasing a thousandth with the really minute details. We want to focus on it being fundamentally sound. And then after that is when we transition to manufacturing.
Wow, yeah, a lot of stages, a lot of phases, and a lot of moving parts. But keeping that under control requires a rock-solid foundation. So now I would like to move on to Nick. Now, Nick, your section underwent what would arguably be the largest change this year. You briefly alluded to it, the changing of the cell type. Now, like me, and for most of you guys who don't know, what does that actually mean for the car?
So for context, the first 3 iterations of our electric vehicle used a cylindrical cell type. And this is basically just like a really big AA battery, which is pretty good, but it's limited because it's a little bit heavy, and the cylindrical shape makes it hard to like squeeze them together, so your battery ends up being a bit big. What we did this year is we switched to a pouch cell, which is basically a bigger version of the cell that you find in your cell phone. And that means that it's taken all the chemicals that you find in your cylindrical cell and your AA battery, and you've put them into a bag, which is a lot easier to like squeeze together. You can make a much higher energy battery and a much denser battery. It's also really difficult to design for. I want to give a huge shout out to Dr. Carlos da Silva, Dr. Christina Amon at the Adams Lab, as well as the members of the team who did research there over the summer. It's thanks to you guys that we actually were able to figure out which cell would suit us best and optimize for our design needs. Thanks to those pouch cells, and thanks to all the hard work we've put into them, we're looking at our lightest battery yet and our highest energy battery yet. It also means the car will be able to drive faster and for longer than ever before, so I'm really excited to see that.
Wow, yeah, that does sound very exciting. And, well, an EV car has a lot of its magic under the hood in places that none of us can see, but are equally, if not more important. So Nick, with these changes and our transition to maturing into an EV team, what are some of the things you've done that we may not be able to see on the car, but have changed our path going forward?
Yeah, there's a lot going under the hood that isn't really visible, and actually the bodywork helps keep it that way, which is a nice thing to have. One of the biggest changes is, again, inside the battery pack. It's that custom battery management system. And so thanks to the circuit boards we have in there, thanks to RLX Solutions for providing them, we are able to implement a system that regulates their battery temperature, lets us charge the battery, and lets us take out the previous solution, which weighed about 2 kilos, took up a lot of space. So that's helped make our battery even lighter, more performant. Another change is that real-time operating system that we're using on our microcontrollers. Essentially, it lets us streamline our data acquisition, make us compute faster, lets the car think faster, basically. The huge thing about that is improving our data acquisition is super key because that's how we make the car go faster. It's really with the race engineers and the section leads getting data from the car, tuning the car so that every time we go to the track, it gets a little bit faster, and that's a really cool thing to see.
Yeah, very exciting. And can we have a round of applause for our RLX solution, all the changes we've had? Now, the mechanical section and electrical section impact the car in very obvious ways. You see their performance, but one section has been quietly making history. And as Yusuf alluded to earlier, the driverless section achieved a monumental goal. It worked. Now, for those of you who don't know, that is a massive change. So can we have a round of applause for them? I believe we have a video of how the car actually ran.
Yeah, so what we're seeing here is a run from last November where you can see that the car is actually moving completely on its own. So this was honestly a huge moment for the team. It was really an accumulation of over 2.5 years of constant struggle and challenges to get us to this point. So it's really an amazing breakthrough for the team to achieve. And as a unit, we're very proud to announce that we are the first ever fully end-to-end running driverless team in Canada. So, yeah.
Wow. Yeah. That's impressive, and there's another camera angle that's not seen here, but of the team. I remember watching the video of everyone on the driverless team, but not only that, the entirety of the UTFR community, everyone was hyped. But, you know, that is a long journey, and we took a lot of steps to get there. Can you walk us through some of the major ones you took this year?
Yeah, so now that we have a baseline system that kind of works, our approach and shift moved from just getting something to move to now we need to get this reliable and consistently performing at this level. So we began to do some overall system improvements. So thanks to our sponsor Peripheral, we were able to get our hands on a new perception camera that gives us a much more reliable image and improves significantly our cone detection accuracy. We've also been doing a lot of improvements to enhance our redundancy. So for mapping, we began to develop a fast SLAM approach to generating the cone map. And this creates a much more probabilistic view of the map and makes it much more resilient to severe noises from our sensor data in localizing the car. Also, for planning, we've developed a colorblind algorithm that essentially only needs LiDAR detections to generate the path that we need to travel in. Thereby, again, in case of anything happening, we're prepared to overcome that and still move on with competition. Additionally, for mapping, we've developed our extended common filters. This is the way we use to localize the vehicle to fuse in much more sensors, like steering angle sensor, wheel speed sensors, so that we have a much more robust way of determining where we are in the track. And finally, for controls, we've been developing an MPC controller along with our other controllers to, again, track our target path as fast as possible and ensuring that we can maintain that speed in competition. And so, yeah, we're hoping with all these improvements, we'll be in a much better position to compete this year.
Yeah, wow, that's a lot of elements coming together. And yeah, it just goes to show that something as simple as moving a car and so on to a track requires that amount of work. Well, that's an ambitious plan across the past 2.5 years that's come to fruition. And now, finally, competition season. So tell us, what is competition season like for the driverless section, and do we have any initial goals we're trying to hit?
Yeah, so this year is hopefully our first year competing with a fully autonomous car. And so a lot of prep has been going into this, so doing simulation-based testing so that we can make sure to catch any errors before we actually throw this thing on the track. And we've also have this sort of driverless cart that we've been pushing around campus. I don't know if any of you have seen us dragging it along, but that's been crucial to collecting as much data as possible to validate a lot of our design decisions and a lot of our software algorithms before we throw this baby on the track and see it run. So yeah, and also since we're pioneers in this field in North America, we've been fortunate to work with other teams in helping plan and shape how driverless will be in North America. And so our goals for the competition is to obviously compete and finish all of our events, which is a major milestone for a first year running DV team. And one of the main things that we strive for is not just to make something work, but to also make it scalable. So we're also looking forward in the future as to different things we can develop and ensuring that year by year, we're not just competing for just completing the track, we want to compete for podiums eventually.
Wow. Fingers crossed for that, and every year I get more and more confident in the driverless team. So, well, now you've seen everything on the car, but the FOD section, Evan, well, as business director, you're working with not only these guys, but a bunch of people, and business functions a bit like the glue of the team. We keep things together, we keep it moving, but can you talk to me, what's the mindset of dealing with these guys, but also everyone at the back?
Yeah, it's a little challenging sometimes, to be honest, working with everybody.
Sometimes.
Maybe more than sometimes, but we like them anyways. But we always try to work to make sure the engineers are able to do whatever they want. We don't want to be the limiting factor on the team. We're trying to work to give them all the resources and availability of testing that is possible. So, example, like Winston was talking about the Ford wind tunnel, all these new components. The business team really works hard to try to supply the team with what they need for success. And that goes from the design phase to the manufacturing phase to testing. We're there alongside them trying to make the car as fast as it can be.
Wow, yeah, there's a lot that goes into making this not only on track, but off track. But anyone who's a fan of racing is a fan of what's on the track. Now, I'd like to invite Ayrton as well to contribute to this answer, but Ayrton, we've driven the car before and after the race engineering. Now, race engineering sounds very fancy, but Evan, maybe you can start by walking us through what it's like being in the cockpit, but now you have another voice in your head. How does that impact your driving?
Yeah, race engineering has really changed how I go about my responsibilities and my focus, what I focus on as a driver at competition. For context, our endurance, our race is quite difficult to finish. Not very many teams finish, so finishing is a big thing. As a driver, I need to keep the car on the track, but I also have to monitor the temperature of our battery and how much energy I'm using. It's a rules-regulated thing that we have to keep our battery pack under 60 degrees. So as you're driving, you got to keep an eye out, making sure you're not pushing too hard, not heating up the battery pack too much, or else you won't finish. And if you don't finish, you get almost no points, so that's a big blow. Also, making sure you're not consuming energy at too fast a rate. It's quite simple. If you use all your energy, you're not going to be going anywhere. Or even if you're able to save it quite at the end, then you're going to be so slow it's going to be uncompetitive. So in previous years, it's been the driver's responsibility to keep an eye on these systems. But now with the race engineering team, the driver can only focus on driving the car as fast and efficiently as possible. And the race engineering team can analyze all the data and have their simulations ready to go to instruct the driver what the best strategy is.
Yeah, that's like a lot of load off the driver's head, and you can just focus on getting to the end as soon as possible. Now, Ercin, there's another aspect of this race engineering, like strategically, how does this impact us at competition?
Yeah, I mean, even before competition, the race engineering, like I mentioned earlier, its main focus is oozing out every last bit of performance we can get from the little time that we have with the car, and that's tremendously important in the preparation. So going testing, having a testing plan, making sure we're sticking to it, making sure that we actually look at the data that we're getting at testing and we're not, goofing around because it's fun, and actually, getting the most value out of the time that we have. At competition, it's a whole different beast. Things go wrong all of the time. It's never a straight ride, and having a race engineer there who has a holistic understanding of the car and what it needs to run and in what conditions it runs best is really where that is at its greatest benefit, because anytime anything goes wrong, you're immediately adaptable to that situation, I suppose the best way to say it. So there are a lot of instances in previous competitions that would have benefited from having someone who understood how different conditions would have affected the way that the car was going to perform, and we maybe wouldn't have spun. Wasn't me, I promise.
Ask Ercin about it afterwards.
Don't. Yeah, but it'll be cool, and it's also obviously, as Evan mentioned, it's great to get feedback, and when we get the dean in the car to go give it a spin, I'm looking forward to it.
Do you have a driver's license? Good.
Yeah. So that's covers that.
You guys can all see we really care about this, and we do not want this ending up in a wall. But Ercin, one last question. You know what it is. As team captain, Ercin has the privilege, but also the responsibility of naming the UT25. So, Ercin, who am I looking at?
Yeah, we always give it a name. This year's car's name is Gina.
So there you go, Gina. And please join me once again for thanking everyone on stage for their time. Thank you so much, guys.
Thank you.
Yeah. And you guys can make your way down, up, and then down off the stage. That'd be great. Thank you. And for everyone else, if you have any more questions, there's ample opportunities later. You guys can come around, see the car close. Please don't touch. But there are also design boards at the back, wonderfully designed by our graphics designer, Amelia. And they can walk you through different parts of the car, so feel free to talk to not only these guys, but all the leads there who have worked tirelessly to making this appear in front of you. So that's about it. Thank you, and Alicia, for the rest of the show.
Thank you, Aranya, and thank you to our directors as well. It's really amazing how much work and thought and passion went into every part of Gina. Now, I want to show you guys a different side of the team. Yes, we do build race cars, but we also have a lot of fun doing it. So we put together a little quick video to take a little peek at the personalities that make this team what it is.
Andrea. The whole composite?
Okay. Probably me or Andrea for sure.
Robert Fursoff. Alex. Andrea.
Nemo.
Also Nemo.
Nemo.
Robert Fursoff.
Robert.
Electrical.
Always Ron.
Nick.
Ibrahim.
I got known for the welding playlist, so I'll just say me.
Oh, definitely Robert.
Juan. Probably Nemo.
Nemo. There's a few.
Naomi.
Clara. Winston.
Matthew.
Ibrahim. Juan.
Nemo.
Nemo.
Nick.
Nemo. The electrical people.
Definitely Robert.
Nick.
All of electrical.
Either electrical or me and Andrea.
Peter.
Me.
Probably Andrew Chen. Like he sometimes stops by once in a while, but nice drippy.
Robert.
Peter. Ayrton's jacket is nice.
Blue Michigan t-shirt. Mine personally is the black ANSYS t-shirt.
Blue Michigan.
The blue Michigan t-shirts from last year.
ANSYS.
The Michigan t-shirt.
ANSYS.
Something from Michigan.
That video as much as I did. Now, I would like to take a moment to recognize special members of our team, our graduating seniors. They spent countless of hours building, mentoring, and also leading. They have not just helped shape our car, but they've also helped us shape the team culture. So now I'd like to invite these people up on stage. Another round of applause. Now let's give them another round of applause. All right. Now, as we celebrate those that are moving on, it is also important to recognize efforts of people who are just begin their journey with us. This past year, we have welcomed a lot of fresh members. They brought fresh energy, creativity, and commitment from day one. UTFR can be intense, but they've committed themselves to sticking along for the ride. Now we just have a quick little video spotlighting a few newest recruits of our team.
Hi, I'm Jackson. I am first year in ECE and I am in the driverless sub-team.
Hello, I'm Julian. I'm a first year track 1 and I'm in the electrical subsection.
I'm Amalia and I'm on suspension.
I'm Aaliyah and I'm on composites and aerodynamics.
Hi, my name's Rohan Sadekar and I'm part of the business team.
Chaotic.
Shambles.
I'm going to say challenging. It was very hard for me to get used to stuff in first year, just as I got in, but I found it really rewarding trying to get through these challenges. It was really nice.
Yeah, I think I'm going to go with what they said before, like shambolic, like, but also really fun. Like you learn a lot happens. Yeah, I don't know, it's just an experience. It's not something you can really like describe. Like, there's good bits, there's bad bits, there's ups and downs. Like, it's what a team is, you know? So.
Passionate.
It's very student run, I guess. I was expecting it to be a lot more structured.
I think the amount of Tim Hortons trips and sparkling drinks that this team goes through.
For me, I didn't expect coming in to have such a big learning curve. Like I literally knew like nothing at all. So getting used to the work environment and working as a team, I found it really nice. So yeah.
No, yeah, I would want to comment on that as well. Like I came in here thinking that like there was like so much to learn and not enough time to learn it. And as I started speaking to leads, they were like, oh yeah, you know, like when I was in your shoes, like when I was your age, you know, back in my day, like I didn't really know as much as you. And like that really gave me the confidence to just like keep trying to learn. And sometimes I go to the shop, I talk with the leads about like something, like some new technical term, like reverse polarity protection or like something simple like op amps or something. And then I'm like, you know, I say like, oh yeah, I get it. And I really don't get it. But then I go home and I wake up the next morning and somehow I get it. Like it's really weird, you know? You learn fast,
There's a strong sense of community and the team is very driven.
I think one of the funniest moments I had happened last week when I ended up cutting my friend Zoe's bangs in the shop because she got adhesive in her hair. So there's a photo of me in the shop giving her a little haircut.
That's cute. Yep. Funniest moments would probably be playing hockey with most of the team. Like, getting absolutely drenched in snow unwillingly, but like it was funny for other people.
Well, I remember one time since I'm in the driverless team, we do everything on software. So I was like fixing my code, and I kept trying to update and change it. And every time I ran it, like nothing would change. I realized like I didn't compile the thing. So I was just sitting there. It's like I have food, and I'm putting salt on the food, but I have like spoon, and it's not going there. So it is a complete mess. But I found it really funny. But we eventually got it to work. So I'm happy on that.
Working on Unveiling and working on the Michigan business plan. A little bickering, a little arguing, but like we all knew that we wanted to do the best for the team. One thing I learned is how to get rejected a lot. As a member of the ER team, I had to send a lot of emails, outreach, asking for sponsorship, and just getting rejected. That's one of the reasons why I'm so grateful for our sponsors currently.
I learned a lot about vehicle dynamics, so like toe, camber, KPI, and then, yeah, that's the biggest thing that I learned.
I think I learned a lot of like more applicable engineering skills, especially as an engineering science student. We do a lot more theory, so I actually like learned how to CAD and what tolerances are, which sounds really stupid, but they never taught us that before. So this team taught me a lot of hard skills.
All right, I'm comfortable in knowing that the future is in such capable hands. Now, I would like to remind you guys that we have custom designed t-shirts available outside. It's a fun way to, support and rep the team. The quantities is limited, so check it out before the stock disappears. Another thing that we have this year is that we have a limited number of spots in the car. So we're opening up these spots through a silent auction. The minimum bid is $150. Reminder, just limited spots, only 5 will make it into the car. So if you want yours to ride with us, make sure to place your bid at the merch table. Our team is ready to help you out there. So that concludes our presentation today. Thank you for coming, guys. Feel free to ask our leads, our execs, if you have any questions about the car. Feel free to look at the car and look at our design boards at the back. Thank you so much for coming. Have a great night. You guys can stand up.